Good morning. Today we will discuss about problem solving technique. This is very important in computer programming. Okay. We will have a problem and we should have the skill for developing or solving that problem. Okay, so we will go through the steps. The computer cannot be used to solve problems until we find solutions. Okay, so we want to find out the solutions. The process of problem solving using computer involve the following major steps. So what are the steps? First is problem analysis. Studying the problem in detail, redefining or restating the problem. Okay, identifying the input available, output required, and constraints in the problem. So we want to identify all these things in order to solve the problem. First thing is we want to study about the problem. We want to understand the problem, and sometimes we may want to redefine the problem. We want to identify the input, output, and the limitations of my solution. Okay, limitations of the problem also. Okay. So algorithm and development and program design. So after studying the problem, we will come to the algorithm development or design. Okay, generating alternative way of solution, selecting the best method among the alternatives, preparing a list of procedures or steps necessary for determining the solution. These are the three things that is required while we are going to design an algorithm. Okay, we may have different algorithms for the same problem, and among them we want to select the best method. Then prepare a list of procedures or steps necessary for determining the solution. So we want to do all the things. Then computing the results. So we want to compute the result. How we will compute the result? We will come after designing the algorithm. We will come to the we will implement that. We will problem coding is there, program compilation and execution will be there, and program testing will be there, and debugging and program documentation. So this will be the steps that we do as a programmer. Okay, but before that, before doing the programming, we have to understand the problem and find out the design. After designing only we can have the computation coding part. Okay, after coding we will have to compile that and we have to execute, and after making the program after completing the program we want to perform testing and debugging. We will check whether any error is there during testing, and if any corrections required we will do that. Finally we will have the program, and what we will do is we will have a program documentation. Program documentation will during that time we will specify all the things in the program so that any other person using the same program can easily understand the program. So we will be studying all that things. Okay. So now we will discuss about algorithm and flowchart. Okay, algorithm and flowchart are powerful tool for learning programming. Okay, it's a very important tool. Algorithm is a step-by-step analysis of the process, while a flowchart explains the steps of the program in a graphical way. Okay, so that is flowchart. Algorithm and flowchart help to clarify all the steps for solving the problem. Okay. So we will discuss about algorithm first, then we will go to the flowchart. Algorithm, the word algorithm relate to the name of the mathematician Al-Khwarizmi, which means a procedure or a technique. Al-Khwarizmi, he developed this. From this name, we introduce the name algorithm. He's a father of algebra. Okay. Software engineer uses an algorithm for planning and solving the problem. Anyway, what is an algorithm? Algorithm is a sequence of steps to solve a particular problem. Or algorithm is an ordered set of unambiguous steps that produce a result and terminates in a finite time. That's a very important thing. It should be unambiguous. There should not be any confusion among the steps. And very important thing, it should have a result. Our algorithm should have a result and it should terminate in a finite time. Okay. Algorithm have the following characteristics. It should have an input. An algorithm may or may not require input. Some program we don't have the input, but some program we will have the input. Okay, input is not a must in the algorithm, but output it should be there. Each algorithm is expected to produce at least one result. One result should be there. Definiteness. Each instructions must be clear and unambiguous. There should not be any confusion in the statements in the algorithm. Finiteness. If the instruction of the algorithm are executed, the algorithm should terminate after a finite number of steps. So it should terminate. Infinite algorithms are mostly not useful. Okay. So this is the characteristics of the algorithm. Okay, algorithm and flowchart include the following three steps of control structures. Okay, algorithm and flowchart have the following control structures. First structure is called the sequential structure. In sequential structure, statements are placed one after the other, and execution takes place starting from up to down. That's a normal algorithm that we write. We will have a start. After that, suppose we are printing hello world. Then the algorithm will be start, print hello world, start. So there is a sequential step will be there in the sequential control structure. Okay. Second is a branching or selection. In branching control, there is a condition. According to the condition, a decision either true or false is achieved. In case of true, one of the two branches is explored, but in the case of false condition, the other alternative is taken. Generally, the if-then is used to represent branch control. Typical example: A greater than B. I am checking using if A is greater than B. If A is greater than B, if that statement is true, then I will say A is greater. I will not talk about B. Okay. If A is greater than B is false, then we will say B is greater. So we are not talking about A. So we have more than one branch will be there, and one of the branch will be executing. That's branching. So we will see this branching. Another important thing is the looping. Loop means repetition. The loop or repetition allow a statement to be executed repeatedly based on certain loop conditions. So there should be a loop condition, and based on the loop condition, we can repeat. So we will have while, for loop, go to, all things are being used in algorithm for looping. So these are the three control structures that we have in algorithm and flowchart. Okay. So next is how to write an algorithm. What are the steps? Okay, this is a typical example showing how to write an algorithm. First is define your algorithm input. You want to understand what is the input of the algorithm. Many algorithms take in data to be processed. Example, to calculate the area of a rectangle, input may be the rectangle height and rectangle width. So we have to input that. Next thing, define the variables. You want to define the variables used in the algorithm. Algorithm variables allow you to use it for more than one place. Okay, we can define two variables for rectangle height and rectangle width as height and width. We should use the meaningful variable name. Example, instead of using h and w, use height and width as variable name. Okay, so we have to follow that. Then third step, outline the algorithm operations. Use input variable for computation purpose. Example, to find the area of a rectangle, multiply the height and width variable and store the value in a new variable area. Okay. An algorithm operation can take the form of multiple steps and even branch depending on the value of the input variables. So all the things can happen. Okay, finally we'll have an output. Output, the result of the flow of your algorithm operation. In case of area of rectangle, output will be value stored in the variable area. If the input variable described a rectangle with a height of 2 and with a width of 3, the algorithm would output the value of 6. So 6 will be outputted. So these are the 4 steps that is required, that we follow while developing an algorithm. We will have, first of all, we want to identify the input, and based on the input we have to write the program, write the operations in that. And during the operation we may require some variables, so we have to declare the variables. While declaring the variable, we have to use variables with a meaningful name should be used while using the variables, and finally we'll have an output. Okay. Next we will discuss about the flowchart. Okay, the first design of flowchart goes back in 1945, which was designed by John von Neumann. Okay, he designed this flowchart. Unlike an algorithm, flowchart uses different symbols to design a solution to a problem. Okay, flowchart will have different solutions. Okay, it is another commonly used programming tool. By looking at the flowchart, one can understand the operations and the sequence of operations performed in a system. Okay, we should know about the flow. Okay, flowchart is often considered as a blueprint of the design used for solving a specific problem. Flowchart is diagrammatic or graphical representation of sequence of steps to solve a problem. So flowchart is like that. Okay, there are certain symbols used in the flowchart. They are oval. Oval is used to represent start and end of the flowchart. Parallelogram used to represent for input and output. Rectangle used for arithmetic operations and data manipulation. Diamond, decision making. It's used for decision making, used to represent the operations in which there are 2 or 3 alternatives, true and false. Okay. So diamonds is used to represent decisions. Arrows are flow lines used to indicate the flow of logic by connecting symbols. So arrows are used for that. Then we'll have a connector used to connect different flow charts together. Sometimes we'll have different flow chart. If you want to combine, you can use this connectors. Okay.